So in the last video we discussed price elasticity of demand. We talked a little bit about some of the things that determine how elastic demand might be, how responsive consumers' behavior is to a change in price, and we talked a little about the usefulness of this this concept particularly for sellers to understand how to increase their revenues, whether to increase their price, what will happen. Not only that people will change their behavior, but by how much people will change their behavior. And so I also warned you that this would get a little mathy. There would be some algebra involved, but encouraged you that it's not a concept that's foreign to you, particularly if you grew up here in the U.S. or in another country where your economy is very market-based. This is something that you see and experience all the time, that people's behavior changes when prices change, and that depending on the type of good or service that we're talking about, behavior may change more or less, right? That's the idea of elasticity. So let's get into the math of it a little bit. Let's talk about how to calculate a value for elasticity of demand. So price elasticity of demand is measured as, or is calculated as, the percent change in quantity demanded divided by the percent change in price. You can make it a little simpler by using some abbreviations here. Remember from a math class probably that triangle is the Greek letter delta, and it means change. So price elasticity of demand, E with the subscript D, is the percent change in quantity demanded divided by the percent change in price. So here is an example that we can work through. University parking pass prices increase by 50%. As a result, 25% fewer people purchase a parking pass. So use the equation, pause the video, use the equation that's given, and see if you can calculate a value for price elasticity of demand for university parking passes. Okay, so what we'll do here is we'll plug in the numbers that are given. The percent change in quantity demanded. We're told that 25% fewer people purchase a parking pass. That's a change in quantity demanded. The change of 25%. And in fact, it's a negative 25%, right? Because it tells you that fewer people purchased a parking pass. So the quantity demanded goes down by 25%. So it changes by negative 25%. And then the bottom of our fraction, the percent change in price, is what we're given in the first line here, that the parking pass prices increase by 50%. So that's a positive change of 50%. So our fraction becomes negative 25 divided by positive 50. You do that math, your calculator can help you with it, and you get an answer of negative 0.5. This is our price elasticity of demand for parking passes based on the information we're given. So let's think about this number a little bit more and think about what it means. So what does the numerical result here mean? We can translate this number from math language into English language, and when we do, what this number tells us is that if the price of parking rises by 1%, the quantity demanded will fall by only 0.5%. So if the price of parking rises by 1%, the quantity demanded will fall by only 0.5%. Right? So does that sound like it's elastic demand to you or inelastic demand to you? In fact, the demand for parking is not very price elastic. It's quite inelastic. How do I know? I know because the price rises by a greater percent than the quantity demanded falls. So, in other words, this is kind of like a big tug. Remember, the price change is like a tug on a rubber band, right? Or a tug on something, right? So the price change is bigger than the quantity change. It's a big tug. We tug hard, but we don't get much change in shape of the object of our rubber band, which means our rubber band is not very elastic, if that's the case, right? In fact, let me pull my paper up over here, and we can generalize this a little bit and say, so if we think about the price elasticity of demand is the percent change in quantity demanded divided by the percent change in price, right? This means that if I want to categorize a particular good or service as having elastic demand versus inelastic demand, I can use this fraction, this equation, if you will, to do it. So if this is less than 1, what does that tell me? If this number, and we'll say absolute value, right? So these lines just mean the absolute value. Let's not think about whether it's negative or positive right now. Let's just think about the numerical result here, okay? So if the absolute value, the number itself, forgetting the actual sign, is less than 1, what does it tell me? If this is less than 1, if a fraction is less than 1, so for example, you know the fraction 1/2, and you know that that's less than 1. What does it tell me that this is less than 1? It tells me the top of the fraction is smaller than the bottom of the fraction, right? So if the absolute value of elasticity is less than 1, that tells me that the top is smaller than the bottom, that quantity changes less than, or by a smaller percent than, less than price, right? It tells me that the top of the fraction is smaller than the bottom of the fraction. The quantity change is smaller than the price change, which tells me that the quantity demanded is not very responsive to a price change. You can change the price a lot, and it doesn't change the quantity as much. This is inelastic demand. All right, and in fact, these principles or rules, if you will apply to all of the types of elasticity that we talk about, not just price elasticity of demand. So, on the other hand, if the absolute value of this thing is greater than 1, what does it tell me? So something like 3/2, right? You know that's 1.5, and it's bigger than 1. How do I know it's bigger than 1? Because the top of the fraction is larger than the bottom of the fraction. That will mean that quantity changes more than, or by a larger percent than, price. This means just a tiny tug on that rubber band is going to produce a large change in shape. Right? So remember, the price is like our tug and the quantity is like our object, the rubber band. If a small price change results in a large quantity change, this is elastic demand. This is where we see a very responsive quantity change to a small price change. And the only other option here is that the elasticity actually equals 1. This can happen in theory whenever the percent change is exactly the same between quantity and price. It doesn't typically happen in reality because it's very tough to find things that are exactly equal in the real world. But theoretically it could happen, and if it did, it has a name. Its name is unitary elastic. Right, so this is unit elastic or unitary elasticity if that elasticity is exactly equal to 1. So so write this down. These will be helpful to you moving forward as you do these calculations, and then you're trying to interpret your results. What does it mean that my elasticity of demand is equal to negative 0.5, right? So look at the absolute value of that. Look at just the number, the numerical result, the 0.5 part, and it tells you that you have inelastic demand because that's less than 1, right? Then let's look at the sign, right? So we've talked about what the numerical result can tell us. What about that negative sign? What does the negative sign mean? It's negative because the quantity went down when the price went up, right? And in the case of price elasticity of demand, it will always be negative because of the inverse relationship between price and quantity demanded, because of the law of demand. When price goes up, quantity demanded will go down. When price goes down, quantity demanded will go up. That's the law of demand, which means price elasticity of demand, which is a change in quantity over a change in price, will always have opposite signs. One of those will always be positive and the other will always be negative, so we'll always have a negative elasticity. This is not the case for every type of elasticity. When we talk about other types of elasticity, you'll see they could be positive or negative. But in terms of price elasticity of demand, it will always be negative because of the law of demand. Now, we've calculated this thing using percent changes. In the previous example, we had it pretty simple. They told us in the problem the percent changes, right? What if they didn't tell us the percent changes? What if instead they told us the number, the numerical changes? So let me pull this over here again, and let's talk about what percent change means. So, percent change. So, for example, if instead of telling you that the parking pass price changed by 50%, what if they had told you that price decreases from $100 to $80? So they don't give you the percent. They give you the actual price change, and then it's up to you to calculate the percent. Now, a mathematician would tell you that we calculate percent change like this. New value minus the old value divided by the old value. Right? So we would have, in this case, our new price is 80. Our old price is 100. It went from 100 to 80. So our new price is 80. Our old price is 100. Divided by 100. We'll get negative 20 divided by 100. So this is negative 0.2 or negative 20%. Right? So this is a 20% change, is what we would see, a decrease of 20%. Okay? What if instead the price went up from 80 to 100? So from 80 to 100. Now let's use our same mathematician's equation to calculate the percent change. Our percent change now is going to be new. Now the new number is 100 minus our old number is 80, because we went from 80 to 100, right? And divided by our old number. Now we have 20 divided by 80, which is 0.25. Your calculator could help you with that if you need it. So, or in other words, a 25% change. Does anybody have a problem with that? A mathematician doesn't have a problem with that, because a mathematician would describe percent change as a change relative to where you started, right? That's what the old value on the bottom means. We're talking about how did it change relative to where we started, which is why we get different values depending on where we started. That's fine and good in a math world, but for an economist, if I want to be able to use this as a business owner, if I want to be able to use the idea of elasticity, it becomes complicated if the number depends on where I started, right? If the number depends on whether the price is going up or down. I'd just like to know what the elasticity of demand is, regardless of whether my price is changing up or down. And so the way we fix that as economists is, rather than saying we want the change relative to where we started, relative to old, we say we want the change, new minus old, again is how you calculate change, right? The new value minus the old value. And instead of putting the old value on the bottom, I'm going to put the average value on the bottom. The midpoint between new and old. This means that when I calculate a price, the percent change going from 100 to 80, so from 100 to 80, now I have my new is 80, my old is 100, so I've got 80 minus 100 divided by the average of the two, the midpoint. What's the midpoint between 100 and 80? It's 90, right? If you didn't know that, you can calculate the average by adding them just the way you always calculate an average, right? 100 plus 80 divided by 2. Add the numbers and divide by 2. It will give you 90. So now I have a change of negative 20 divided by 90. I am going to request the help of my calculator here. So 20 divided by 90, and I get a change negative 22% approximately. Right? What if I went from 80 to 100? Now my new value is 100. My old value is 80. The midpoint is still 90. The average of 180 is the same whether I'm going from 100 to 80 or from 80 to 100. That is the advantage of using this method. Now I get the same exact percent. One of them's negative, one of them's positive, because that's the up or down piece, but they're exactly the same number. This is why we will, instead of using the definition or the formula for percent that mathematicians use, we will use the midpoint method. Right? So the midpoint method is the way to calculate elasticity that corrects that problem, that we get a different number whether we're going up or down. So we'll calculate elasticity as the percent change in quantity divided by the percent change in price. And now we're calculating percent change by doing the change, so that's the new minus old part, divided by the average of the new and old. and the change in price divided by the average of the new and old price, right? It becomes ugly. It becomes this big, long equation, but you just saw me work on it, right? And so what I would do as you're working on homework is do it in pieces. Always calculate these pieces and then put them together, right? So the change in quantity is the new quantity, Q2, minus the old quantity, Q1. The average of the two is just the midpoint. So sometimes you can just eyeball the midpoint, like between 100 and 80. Obviously, the middle between those two is 90. If you can do that, then you can avoid this calculation piece. But if you don't trust yourself, you can always calculate the midpoint by calculating the average, right? Add Q1 and Q2 together, divide by 2. And then you'll do the same thing for price. And then you'll divide. So for example, pause the video, see if you can calculate the elasticity, price elasticity of demand for these pairs of old price, old quantity, new price, new quantity. Okay, so if you plugged in the numbers, you would get this, right? So you plugged in old quantity, new quantity, divided by new quantity plus old quantity divided by 2. Old price, new price, divided by new price, old price divided by new price, old price divided by 2. Right? And again, I would do this in pieces. So 25, first figure out what the midpoint is. 15 plus 25 divided by 2. The middle point between 15 and 25 is 20. Right? Then do 25 minus 15 divided by 20. Then figure out the middle point in the prices. The middle point between 6 and 4 is 5. Then calculate 4 minus 6 divided by 5. Then you'll have 10 divided by 20 over negative 2 divided by 5. Do the math, and you get negative 1.25. Now what does that tell us? The numerical result, 1.25, is greater than 1, which says we have elastic demand, right? And we have a negative sign, which is what we'd expect, because price and quantity always move in opposite directions when we're talking about quantity demanded. Okay? You'll have more practice with this with homework.